Hello everybody, my name is Omid Rohanian and I'm a Senior Research Associate at the Computational Health Informatics Lab as part of the Department of Engineering Science at the University of Oxford. My research is about natural language processing and artificial intelligence, and within the Pandemic PACT project in the last year or so, I have been tasked with the integration of AI into the pipeline of the project. A project with the magnitude of Pandemic PACT has to deal with a large number of research projects. Manual categorization of these projects suddenly becomes a challenge when you deal with a vast data influx. AI and machine learning has the ability to automate part of this process and expedite it by identifying patterns and suggesting annotations to the human annotators. In this way, we can say that we're using AI as strategic aid to complement the work of our team. And this way we can streamline analysis in order to spotlight research funding trends and key gaps. Using this figure, we can schematically show this human-in-the-loop process, using which AI generates draft annotations, which can act as a first-pass filter. These undergo human evaluation. Using the expert review, we can feed this information back into the model by modifying our input and then revise the output again. And this loop continues until we reach a high standard of accuracy. This collaborative model can boost efficiency and maintain data quality. The technology we are using for the AI component of the work is called large language models, or LLMs for short. These are advanced AI systems that are designed to understand, interpret, and generate human language. They have been trained or pre-trained on vast amounts of data. This gives them the ability to discern complex linguistic relationships and structures and also follow instructions, which is a very valuable asset. This is very useful because we can use that to automate certain tasks, including classification, and in our particular case, classifying biomedical texts. This can potentially enhance data analysis. The way to interact with a language model is through a prompt. A prompt is a textual query that formulates the problem. In our case, the prompt has the following structure. We first list all the research categories and their nuances, and we provide examples to teach the model about the task. Technically, this is called few-shot learning or in-context learning. In the end, we specify the expected format for the output. So as you can see in the figure, the prompt is fed into the model and the generated text is the output. We need to do a bit of post-processing to extract the intended output. As was previously outlined by my colleague Emilia, we have a number of research categories that we want to map to the projects that we are considering. In terms of machine learning, this is a multi-label classification with primary or main and secondary categories for each case. But not all of the projects have both categories. The bar plot in the middle shows the distribution of projects with multiple categories. The ratio is 1 to 3. In other words, most of the projects are single category for which there is no secondary category. Hopefully the model would pick up on this during the classification process, because this is specified in the prompt and by using the examples. The input to the classification model is primarily based on abstract and title. We only use very limited metadata for bookkeeping purposes. But the decision to map each project to categories is solely happening using the textual input, the title and the abstract. Earlier I mentioned that we use a human-in-the-loop evaluation process to get feedback from the human annotators and iteratively build on top of that. We use both qualitative and numerical evaluation to make sure that the outputs of the model are practically useful. Qualitative evaluation involves working closely with our human annotators and asking them for feedback regarding the quality. We would ask the question, is the model output practically useful? If the model noise is too much, then we try to identify the patterns in which the model went wrong, and then we would go and revise the prompt structure to make sure that the outputs are better. So that's one way of doing it. We also can use numerical evaluation that we have already, using some of the standard metrics that you can see listed here, to also have a better idea of where the model fails and where we are standing with regards to model performance. We have already processed 2 batches of data. One was 500 projects, the other more than 2,000. We have already received the feedback from our annotators regarding these 2 batches, and we continually develop the model to become better and better based on the feedback that it receives. To wrap up, we will continue to rerun some of these experiments based on the feedback that we receive. We consider experimenting with different open source models in a GDPR compliant way. And one of the things that we will consider going forward with the team would be streamlining the data flow so that models can be continually run in a semi-autonomous way. And we will also consider fine-tuning the models on the gold standard annotated parts in order to make the performance better, because at the moment we are using the models in a frozen way and relying on the internals of the model and the prompt only for the outputs. I would like to extend my gratitude to all the individuals and organizations who have helped this element of the work. And on that note, I would like to hand over to my colleague, Dr. Louise Siegfried, who will now talk about the rapid research needs appraisal. Thank you very much for your attention.